Thank you very much, Caroline. It's my pleasure and privilege to be moderating this first dialogue in the final science session of the Nobel Summit. Today, I think we are experiencing and expecting many more exciting opportunities for human progress driven by innovations. The technological innovations are leveraging and combining developments in artificial intelligence, in biotechnology, nanotechnology, etc., whereas the social innovations are being driven by a much more informed, demanding, and doubting society, contributing to both co creation and consensus based innovation. The growth of citizen engagement and public activism is also leading to innovations in planning and policy making. These two developments can, if harnessed effectively, counterbalance the negative effects of technological developments, as warned by Johan Rockstrom actually earlier in the summit, increasing the probability of our being able to achieve global sustainability. Additionally, and very importantly, however, the global challenge of inequality will have to be addressed squarely and upfront to really ensure resilient societies too. As you already heard, we have a very eminent panel of speakers today who are leaders in technological and social innovations and are also deeply empathetic to issues of inequality and ethical use of innovations. I'm going to invite our speakers to make their interventions in the sequence in which they are listed. Our speakers will make 5-minute introductions of the topic they would like to speak to, followed by a question answer session. But before I introduce them, I would like to strongly encourage all participants to raise questions to the panel via the chat box or the Q&A option as is available to you. I'll finish with the introductions first so that we can move through the speakers one after the other. First speaker would be Dr. Richard Roberts. He's the Chief Scientific Officer at New England Biolabs, Beverly, Massachusetts. He received a PhD in organic chemistry in 1968 from Sheffield University and worked as a postdoctoral fellow at Harvard before moving to Cold Spring Harbor Laboratory. In 1977, his lab discovered split genes and mRNA splicing, for which he received the Nobel Prize in Medicine in 1993. And in that same year, his lab, in collaboration with Xiaotong Cheng, discovered base flipping. Rich now focuses on bioinformatic analysis of genome sequences and studies of bacterial DNA methylation. Our second speaker for the day would be Dr. Jennifer Doudna. She is a biochemist at the University of California, Berkeley. Her groundbreaking development of CRISPR-Cas9, a genome engineering technology that allows researchers to edit DNA, with collaborator Emmanuel Carpentier, earned the 2020 Nobel Prize and forever changed the course of human and agricultural genomics research. She's also the founder and president of the Innovative Genomics Institute, the Li Ka-shing Chancellor's Chair in Biomedical and Health Sciences, and a member of the Howard Hughes Medical Institute, Lawrence Berkeley National Lab, Gladstone Institutes, the National Academy of Sciences, and the American Academy of Arts and Sciences. She's a leader in the global public debate on the responsible use of CRISPR and has co-founded and serves on the advisory panel of several companies that use this technology in unique ways. Doudna is the co-author of A Crack in Creation, a personal account of her research and the societal and ethical implications of gene editing. Our third speaker for today is Karen Cito. She is the Frederick C. Hickson Professor of Geography and Urbanization Science at the Yale School of the Environment. Her central research focus is how urbanization will affect the planet. A geographer by training, she integrates remote sensing, field interviews, and modeling methods to study urbanization and land change, future urban land expansion, and the environmental consequences of urbanization at scale. She has pioneered methods to reconstruct historical land use and to develop empirical models to explain and forecast the expansion of urban areas. She has many more things to her credit, which I'm going to abbreviate with your permission, Karen. She's co-leading and co-led the urban mitigation chapter for the IPCC 6th and 5th assessment reports. She chaired the US National Academy workshop with the Chinese Academy of Sciences on advancing urban sustainability in China and the United States. She's an elected member of the US National Academy of Sciences and the Connecticut Academy of Science and Engineering, and a fellow of the American Association for the Advancement of Science. Our last speaker in this dialogue is Professor Frank Heels. He's Professor of System Innovation and Sustainability at the University of Manchester. Frank is a world-leading scholar on sustainability transitions in energy, mobility, buildings, and agri-food systems. He's well known for his work on the multi-level perspective, which conceptualizes the main processes of change using insights from evolutionary economics, innovation studies, institutional theory, and political science. He published 6 books and 83 peer-reviewed articles in many leading journals and was selected in the highly cited researchers list over 2014, 2019, and 2020. Frank is the lead author of the Working Group 3, contributing to the 2021 IPCC report, member of the Scientific Committee of the European Environment Agency, and member of the World Economic Forum's Global Future Council on the new agenda for economic growth and recovery. So with those words of introduction and to allow us to flow through the dialogue, let me first invite Rich to make his comments in about 5 minutes. Rich, please.
Okay, thank you very much, Leena. What I plan on talking about are things that are directly related to what's going on at the moment, namely the COVID crisis. I think we've seen 2 tremendous advances since the crisis began that are very much driven by biotechnology. The first of those was the development of some rapid tests, and they continue to get improved. They're really wonderful way of actually celebrating a gentleman who won the Nobel Prize the same year I did, Kary Mullis, who invented PCR. And PCR for amplifying DNA has become absolutely crucial. But there are other ways to amplify DNA too, and these have found their ways into novel tests that are being fairly widely distributed. The one thing I would say about testing is that it took an awful long time to get FDA approval for a lot of these tests to get on the market and into the hands of researchers. And I think as a lesson for the future, we should figure out a much better way of getting groundbreaking biotechnological innovations into the hands of the public. This would be very much appreciated. We were doing tests in China with a method that we developed back in February, and it's only about a month and a half ago that we got permission to do it ourselves here in the US. This is an area we can definitely improve on. The other amazing thing that has come about has been the development of the messenger RNA vaccines. This has really shown a new, clever way of making vaccines. And it's also a very good example of how we don't always support science when we should. The 2 individuals who developed the technology, Katalin Kariko and Drew Weissman, managed for many years with little government support, with very little support from their peers, in fact, in many cases, and yet they came up with a technology that allowed the first vaccines to be developed in a very few months, 8-9 months, which is really unprecedented for vaccine development. And not only were they done fast, they turn out to be a little more effective than the traditional ways of making vaccines. And I think this is tremendously promising for the future because now that we know it can be done, we know these vaccines are safe, we should be able to use exactly this same technology, not just to tackle pandemics in the future, but also to tackle existing diseases where new vaccines could be extremely useful. And I'm rather hoping this year, when the Nobel announcements are made, that Katalin Kariko and Drew Weissman will be the recipients of the Medicine Prize. I can think of no better year for that to happen. This is really wonderful. Now, there are many other aspects of biotechnology that have become very important and are really useful. And I would just want to mention one that is particularly close to my own heart, and that is the need to respond to climate damage by growing plants that are more resistant to the various climate changes that are going to take place. And nowhere is this more important than in the developing world, where the population is growing, especially in Africa, and they are having trouble feeding themselves. And if they were allowed to use GMO technologies in order to improve the crops that they grow and that they eat, this would be just a wonderful advance. But unfortunately, the Europeans have taken a stance against the use of GMO technologies for reasons that really escape me, but seem more connected to political and financial interests than to science. And I think this is an area where we really need to get some progress made so that the developing world can really benefit from these technologies. And finally, the Europeans are beginning to think that maybe they need them too, because the climate in Europe is also changing. And many of the crops that they grow do not yield things in the way that they used to. They don't have the same yields. And so this would be also something that would be very good, not just for Europe, but for the whole world. And the science behind this is so strong that to deny it is really ridiculous. So I'll close at that point and let Jennifer take over.
Thank you very much, Rich. Jennifer, may I invite you for your comments?
Thank you very much, Leena, and it's a real pleasure to be here. Rich, your comments are very interesting, and there's a few segues to what I wanted to say. So first of all, I thought I would just give a very brief introduction to the Crispr technology. This is a tool that is used for altering DNA sequences in cells, and it's become really a kind of a globally adopted technology for manipulating genetic material in basically any cell type or organism. So it's been a real transformational opportunity for biologists. Anything that has DNA can be manipulated using this technology. And it's meant that scientists can study the functions of genes, not just one at a time, but whole sets of genes, and do that in a targeted fashion in a way that previously was either difficult or in some cases impossible to do. This is I think it's a great example of the importance of fundamental research, because the work that I did with my collaborator, Emmanuel Charpentier, and a number of other folks that were contributing in this field were motivated by understanding the fundamental biology of a bacterial immune system called CRISPR, which in nature is used as a way that microbes detect viruses and destroy them in real time. It's an adaptive system that relies on RNA molecules. So we're hearing a lot about RNA today to detect viral genetic material. And I'll just, as an aside, I'll mention that it's also being used right now in this current pandemic as a way to directly detect the viral RNA of SARS-CoV-2, the virus that causes COVID-19. So it's become a tool that can also be deployed as a diagnostic in this setting. But back to genome editing. So I thought I would just briefly mention 3 ways that CRISPR is already having an impact and will do so even more extensively in the future. So currently, and in work that's gone on over the last 8 years or so, there has been increasing effort to use CRISPR as not only a gene function discovery technology, but as a way of therapeutically intervening with genetic sequences that cause disease. And a great example of this is sickle cell disease. It's one of the genetic disorders that's been studied perhaps for the longest. We know a lot about the cause of this disorder, as well as the effects on patients. And CRISPR is in many ways a terrific agent to treat this disease at the source, because we now have the capability of altering the mutation that causes sickle cell disease or activating a second gene that would basically suppress the effects of the mutation. And that's not a fantasy, that's actually already happening. So there are about 30 people that have already been treated with the CRISPR technology clinically. The first one to be treated in the US is named Victoria Gray, and she's made headlines over the last 2 years because the therapy has been highly effective for her and for others like her. And so this gives, I think, all of us in the field tremendous excitement about what lies ahead. But for this group, I also want to point out that as exciting as the technology is, right now that therapy costs about $2 million US per patient. Clearly not a price point that will be affordable for most people globally that need this. And so with my colleagues at Berkeley and at UCSF, I started the Innovative Genomics Institute a few years ago with the idea, with the goal of focusing on genome editing applications that can make a difference in people's lives, including clinically, but with a lens towards making them affordable and accessible to those that need them. How do we do this? Well, we think one of the important ways is to make sure that genome editing molecules can be delivered into patients efficiently. And so we're working hard on ways to, in the case of sickle cell disease and related disorders, provide genome editing medications without requiring bone marrow transplantation. And that's something that, again, kind of guides our thinking as we develop the technology further. And finally, just in the last minute, I want to point out that the technology is very important agriculturally. So this circles back to something else that Rich mentioned, which is that addressing climate change, we think, is one of the most urgent challenges we face globally. And genome editing will be a really important technology for this as well, because we can now manipulate plants in ways that you mentioned, Rich, do that much faster than traditional plant breeding. And of course, we need to do that with an eye towards responsible use and appropriate regulation. And that's, again, a challenge that we have. Thank you.
Thank you very much. Let's move on, then carry forward and request Karen Sito to make her remarks. Thank you.
Oh, thank you. Well, I want to start by saying that if we look back at history is filled with a number of technological innovations that changed how societies literally saw the world and subsequently how we understood the world. And I just want to highlight three things: the microscope, the telescope, and the camera. Each of those fundamentally transformed our ability to see beyond the naked eye, whether it was up close or far away, or in the case of camera, by stopping motion. And today we're in actually a very similar transformative time in human history, and that is the widespread availability of satellite data. Remote sensing data from satellites is literally transforming our ability to see our planet from new perspectives. And this is enabling new understandings of human activity on the planet. A number of the issues that have been discussed at this summit, climate change, biodiversity loss, human health, and equity, a number of these issues actually have another issue at the center, and that is the urbanization of societies, economies, and the planet. Urbanization is actually at the center of many of these grand challenges facing society. And if we look at the technological advances with remote sensing is enabling us to see and understand a number of these grand challenges, whether it's climate change or biodiversity loss or urbanization. And one of the things about urbanization that is particularly unique in the context of just global challenges is that it's something that is transforming a number of societies and economies all around the world. It's not just something that's affecting one country or one locale, but it's literally a planetary trend. So just to put this in perspective, every single day, an area that's equivalent to about 20,000 American football fields becomes urbanized. Some of the most productive agricultural lands and some of the most biologically diverse ecosystems around the world are being lost to urban expansion. We also know that urban areas generate about 75% of fossil fuel CO2 emissions, and the top 100 emitting cities worldwide account for about 18% of the global carbon footprint. And every single week, the planet is adding 1.3 million people to cities and towns all around the world. And so urbanization and cities are at the center of so many of these challenges that we're talking about. And we need to find solutions not for one city or two cities or even for the top 100 cities. We need to think about solutions for all cities around the world. And this is, again, where remote sensing comes in. Remote sensing imagery is or can be a central element in developing solutions that can transition societies to be more equitable, healthier, and sustainable. So NASA launched the first Earth observing satellite in 1972. And today there are over 850 Earth observing satellites. But most of these satellites were designed to observe natural ecosystems and natural phenomenon. But we actually have one satellite that was launched 10 years ago that is primarily looking at human activity. And this is a satellite which is called VEERS, and there's a product that is called the Black Marble. These data are being collected daily, and it's basically satellite imagery of Earth at night. And so data collected at Earth at night provides us with new understanding of human activity in a way that other satellites have not been able to provide. So this particular technology, NASA's Black Marble, is enabling a wide variety of applications with, a lot of applications ranging from looking at economic activity to looking at monitoring changes in energy use and infrastructure, to looking at wildfires and the effects of hurricanes. So I'll just end my comments by saying that satellite imagery and satellite analysis is one of these technologies that's really transforming our understanding of human activity, but specifically this Black Marble product, this daily available product, is really allowing us to track human activity, things like vulnerable populations, in ways that we haven't been able to before. Thanks.
Thank you very much, Karen. And Frank, the last word for you on this round.
Okay, thanks, Leena. I'd like to make 3 contributions, which will focus on transition dynamics and governance. And I will draw explicitly on social science research on system transitions, which is a field that has emerged in the last 20 years. So I've got some slides, 2 slides to share. So there are many sustainability innovations. There are many sustainability innovations in energy systems, food systems, and mobility systems. These include technical innovations like electric vehicles, plant-based milk, solar and wind energy, but they also include social and business model innovations like community energy, urban farming, car sharing, and alternative food networks. The problem is that most of these innovations are still small and confined to small niches and demonstration projects. They're not diffusing at sufficient speed to address global problems like climate change and biodiversity loss. So drawing on transitions research, I'd like to make 3 points. The first point is that we should not only stimulate the emergence of breakthrough innovations, but also drive their diffusion, because only that will bring about system transformation. So to elaborate that point, the next slide shows a schematic figure which suggests that transitions happen through interactions between 3 levels: novelty or breakthrough innovations at the micro level, a deeply entrenched or locked-in existing system at the meso level, and exogenous trends and developments at the macro level. Socio-technical transitions thus have complex system dynamics, including interacting fast and slow dynamics, gradual build-up of pressure, external shocks, tipping points, and punctuated equilibria. So in the first phase, radical innovations emerge in small peripheral niches and local demonstration projects, visible in the left-hand corner of the figure. In the second phase, these innovations find small market niches where they stabilize into a dominant design. But widespread system transformation does not happen until the third phase, when innovations actually diffuse into mainstream markets and society. So as shown in the figure, diffusion may be accelerated by external macro shocks that disrupt existing systems and create windows of opportunity. The pandemic is obviously a clear example, as other speakers have noted yesterday. But diffusion also depends on endogenous drivers, like cost reductions and performance improvements, business investments and innovation raises, consumer enthusiasm and adoption, positive cultural narratives and visions, and supportive policies that actively create markets through purchase subsidies, capital grants, or even regulatory bans that are now being used to phase out incandescent light bulbs and diesel cars. Feedbacks between these 5 drivers are now accelerating the diffusion of solar panels, wind turbines, and electric vehicles. But they're not yet driving many other green innovations, which therefore remain stuck in niches. This means that stronger policy, business, and consumer engagement are needed to help diffuse these innovations in the coming years. My second point is about resistance to change from powerful incumbent industries, which are located at the meso level of the figure. Oil companies, coal companies, and agribusinesses have now woken up to the threat of sustainability transitions to their business models. And to protect their vested interests, they're trying to slow down the pace of change. So to drive sustainability transitions forward, policymakers can choose 3 strategies with regard to incumbents: forcing, helping, or moving around them. The first strategy is to use stronger regulations and financial incentives to force or entice incumbent firms to reorient in green directions. The second strategy is to help the millions of coal miners, truck drivers, and dairy farmers to learn new skills and find new jobs, so that sustainability transitions will be just and inclusive. The third strategy is to move around incumbents by supporting new entrants who are more willing to drive radical innovations. My third and final point is that policymakers and scientists should not adopt a top-down technocratic approach in steering transitions. Such an approach is likely to fail because there are too many uncertainties and disagreements about future transition pathways. In the early phases in particular, policymakers are therefore well advised to use participatory, deliberative, and learning by doing approaches. These allow stakeholders to express their views and enable policymakers to learn about the pros and cons of different innovations. Later diffusion phases will require generic policies that increase selection pressures, such as carbon taxes, which were discussed yesterday, but they also require more focused policies, such as adoption subsidies, investment grants, or deployment targets. So to conclude, sustainability transitions are beginning to unfold in some sectors and countries, but not yet at sufficient speed. The required breakthrough innovations exist in small niches, but their wider diffusion requires stronger policy support, deeper societal engagement, and a willingness to take on vested interests. Thanks for your attention.
Thank you very much, Frank. And with that, I think we do have a few minutes to engage in a discussion. And I would like to once again remind the participants to put in your questions in the chat box or in the Q&A box in Zoom. Let me start with the first couple of questions. The first one can be addressed by both possibly Rich and Jennifer. And the question is that the COVID crisis has demonstrated the importance of science capacities in all countries of the world, either from a discovery or from an adaptation perspective. So how can these capacities be built to accelerate global responses and uptake of technologies? Can you place the examples that you provided for the technologies that you discussed in the context of rapid transformations towards just and sustainable futures? So it's one thing basically to have the technology, but quite another to ensure that we head towards equity. So Rich, maybe you can go first.
Okay, so let's just deal with the vaccine, the mRNA vaccines, because I think this is a good example of a technology that, while it's absolutely breakthrough, is not that easy to immediately disseminate around the world. That is, technically, to produce a vaccine, once you have the relative sequence of the messenger RNA, to take that to a vaccine is a very complicated process. And one of the things that we're lacking at the moment is often a good supply chain with which we can actually bring all of the elements necessary to market, and also the supply chain of scientific expertise to bring it to market. And this is something that the companies that develop it would be very good if they could make a positive effort to disseminate, to train scientists in other countries how to do it so that it can be disseminated. And of course, the whole patent issue comes to play at this point. We need to find better ways so that we can disseminate technology without having it blocked by patents all the time. I understand the need for patents. I think it's fine, but there are ways in which we can disseminate information and disseminate skill and not have the companies that developed it suffer necessarily. But that's at a level of government. It's above my pay grade.
I would just comment on the diagnostic piece for COVID-19, because I think that's another example where, as you mentioned in your comments, Rich, there is a very important opportunity to make sure that diagnostic technology is made available globally to those that need it. Right now in India, clearly there is just a really urgent need for all kinds of interventions, but testing, I think, has to be part of it. And I continue to feel that everywhere, here in the US and elsewhere, it will be of importance to continue surveillance testing going forward. I keep hearing anecdotal examples of breakthrough cases that happen even in folks that have been fully vaccinated. So I do think we have to understand the dynamics of this virus, especially with viral variants that continue to break out. How do we do that? I'm excited about the CRISPR technology in this regard, because I think it offers an opportunity for direct viral detection that actually doesn't require nucleic acid amplification. So it's, in principle at least, it is amenable to more of a point of care or even an at-home kind of technology. It doesn't necessarily require a laboratory for testing. That being said, we have to figure out how to get it into a format where it can be easily deployed in a manner that provides meaningful data. And that's kind of, I think that's where the field is currently, is figuring that out. And of course, appropriate regulation will be critical. It's become very difficult to get authorization for these types of tests here in the US. And I think that has to be thought hard about too, to make sure that regulation doesn't prevent deployment of useful technology.
Yes, I would agree with that completely. We need to make sure that government regulation doesn't stop these tests getting out. And one of the problems is that if we say it's dangerous in the US or it shouldn't be done, so many other countries just follow our lead without thinking about it.
Thank you both. I think if we have time, we'd probably like to come back to the question of how to make it easier for governments to give you the regulatory approvals that are required. It's not an easy task. But just to bring our other panelists also into the discussion, there is a question from Professor Francis Wesley from the Waterloo Institute, which goes as follows: that while we may have both the technologies and the knowledge of how to move towards a sustainable future, how will we mobilize political will to implement, adopt, or diffuse these ideas and technologies, particularly in the light of increasingly polarized factions in government and in the broader society? So maybe Frank, would you like to take this?
Yeah, well, that's the big issue almost. How do we mobilize political will? And I agree we need that, but it's a bit too voluntaristic, as if policymakers can just decide on their own, yes, we're going to do it. So a better approach is to have a more processual view. You need support coalitions behind you. So you need to first stimulate these emerging innovations, to build the support networks, to have small businesses behind it, who can have the case for, there will be jobs, there will be growth, there are benefits. You need to talk to consumers. You need to build a positive cultural narrative as well. Because otherwise you get, I mean, the problem, Rich, with Europe and GMOs is that they were labeled as Frankenstein foods. And that once you have that label, it's very difficult to get social acceptance. So it's not just about political will, it's about building business support, getting society along. So you need to nurture these debates and you need to start moving. Only then can you gradually escalate the political will. And it's not something that you can just wish up out of thin air. It's a more gradual kind of process.
Thank you. Yes, please, Karen.
Yeah. Well, NASA's astronaut William Anders, he took the first photograph of Earthrise during the Apollo 8 mission. And many have called that photograph the most influential environmental photo ever. I think many of us have that image in mind, right? That Earthrise over the moon. And here, I think remote sensing also plays a very important role. I mean, there's nothing like seeing your home or your community or your region potentially being affected by whether it's sea level rise or storms. And so there is tremendous power in images and imagery, and especially of our planet, in getting people, I would say here, not just policymakers, but regular people to have them understand how the planet is changing and how they may be affected by these changes.
Thank you.
Right.
So once again,
one of the problems there is that images can be used for good and for bad, and that's what happened in the GMO campaign.
Mm-hmm. Yep. Absolutely. And I think it's also the question also arises that, images are good to make an impact, but will they lead to the decisions that you really want? We are, as you said, Karen, also that generating a lot of evidence through many new technologies and sources that are available to us. And yet that evidence-based policymaking kind of skips us. So it's a real challenge. Can I ask you a specific question, Karen? This is to do with urbanization. Has COVID-19 given us an opportunity to totally reimagine cities? You spoke about urban expansion and the footprints. And if so, how?
Yes, well, I mean, it's very clear that, I mean, again, going back in history, cities have been at the center of pandemics, a number of pandemics, and cities continue to reemerge from these pandemics, and they get reorganized. Our modern sanitation systems around the world emerged out of pandemics many centuries ago. And I think COVID-19 is forcing us to rethink, I would say, not only about how we organize cities, but very much about the institutions and governance around cities and around health. There are plenty of examples around the world of cities, big cities, dense cities, that were able to escape the devastating impacts of COVID-19 because they had the institutions in place. A good example of that, I would say, is Taipei and Taiwan. I mean, they've done incredibly well. They learned a lot from SARS, and they had the systems in place. And that has become very clear that we need to think beyond just the density issue, but it is issues of institutions, of governance, of capacity.
Okay. Thank you. Can I come back to Rich or Jennifer? Let me just make sure that I don't have any questions in the chat box. Okay. On the issue of trust or of science communication, especially the science policy or the science society gaps that we have, and the access to information technology and the multitude of opinions that we have over there is not really helping the cause of science. How should one overcome this challenge?
You first, Rich.
Yeah, no, you go first this time.
Oh dear. I mean, that is a very, very difficult question. I'll just tell you my thoughts about it, but I don't have a magic answer to kind of resolve the issues there. as you said, I think, the availability of information, on the one hand, it's great. On the other hand, it means that any kind of information is out there, and all kinds of misinformation or just things that are flatly wrong get circulated widely all the time. And we see this in lots of different areas, but it's true in science as well. And I don't know if there is a magic bullet to solve this problem, but I do think that all of us who are scientists do need to be involved more than maybe we have been traditionally in discussing our work and making it clear why we do what we do. The value of science in society, I think, needs to be more of a topic of cocktail party conversation when that becomes possible again. And I just think that science needs to be woven more into our daily lives than I think it has been, at least in recent decades, because I think for people to appreciate science and technology, they need to know scientists or think they do, and understand why we do our work. We don't want to have scientists sequestered away and siloed and not discussing the impact of our work more broadly. So I think it involves changing our educational programs so that we have our curricula are set up so that students are being trained from an early stage to think about how to describe their work, not only in a detailed technical setting, but also to be able to give a high-level description of what they're doing and why to people. Because I know I was not trained that way, and I think that it's really important that scientists be taught that this is part of our work. Actually, is not only being technical experts, but also being able to discuss the importance of our work more broadly.
Thank you. Very brief comment, Rich. Yeah.
Yeah, I would agree with that totally. That I think one of the things that we've not done very well on the whole among scientists is to talk about our science to the general public in language that they understand. So many of us get up and we give a talk and we use acronyms and we use words that are not commonly used, and we think that this makes us look super smart. In my view, it makes us look stupid. It is much better if you can explain what you do every day in words that everybody understands. And I think if we do more of that, and perhaps we should teach scientists as part of their curriculum how to do that. I know I was taught to do that when I went to school in England, starting at about age 7. We had to get up in front of the class and talk about things, and we were told how to do it. And maybe we should go back and teach scientists in particular how to do that. I have something called the grandmother test, which I tell students, you've got to be able to explain what you do every day to your grandmother so that not only does she understand it, she can tell all her friends what you do and how smart you are as a scientist.
Thank you. Last word to Frank.
Yeah, I think the governance problem is bigger than only that. I think if you look at society, there is so much anger and fear and frustration comes out in many ways. The distrust of experts goes beyond scientists. It's a wider fear. People feel it's about anger about inequality. People feel change is going too fast. They're not being listened to. They're being left behind. They're being disadvantaged. So that's my point about the transitions or transformations have to be an inclusive societal project. Otherwise, we can move ahead with some technologies, but there will be a huge backlash, as you are beginning to see in some countries. It really has to be not only a technical and economic project, but also a societal project to this transformation. And this fear and anger that is about, it makes governance generally, not just for science, but more generally quite difficult. So we do need to broaden it out, I think, the whole transformation project.
Thank you very much. And with that, I think we are a couple of minutes over our time. I'd like to thank all the speakers in this particular dialogue for putting their fingers so clearly on the key problems that we are facing to ensure that the innovations that we have are actually going to be able to lead to sustainability transformations in society. I hope that we will be able to address these challenges. So with that, Caroline, may I turn it back to you? Thank you all once again.